Okay, welcome back to some more Fluids Lab videos. I haven't posted in a while. I've recently added a new a new lab for which I'll be making another series of videos for the Pelton Turbine. Okay, so this is basically not quite a full lab, or at least as it stands as I make this video right now. Currently, we're working this in with the impact jet lab. Because the concepts feed off of each other. Effectively, this is the dynamic version of the static impact jet lab. Okay, but I'll go over some of the objectives here. So what we're going to do is we're going to measure the rotational power of turbines of varying shapes. So the goal is for us to start with a vane shape that is given to you, and then you'll be hopefully designing your own vane shapes. This semester I'm not doing it that way, so sorry if that's confusing to my current students, but you'll eventually be designing vanes of your own concoction, and you'll be testing them and comparing that to the vane that's given to you. Okay, so yeah, we'll measure rotational power of turbines with vanes of varying shape. We'll compare those measured speeds to those determined using the momentum integrals. Now, those are going to be very similar, and I'll go over in a video in a little bit how the equations change, but basically they're based off of the static equations from the impact jet. Okay, yeah, and we're going to study the effects of flow rate and vane shape and how they affect your rotational speed. Okay, pretty obviously, if you increase your flow rate, the speed of the turbine will increase. But yeah, if you change the shape of the vane, it'll affect the thrust force of that vane, and we'll change the speed as well. Okay? Yeah, and we'll apply conservation principles. A little bit of an explanation of this down here. I'll go into a more in-depth explanation when I do the equations video. But basically the way it sort of changes with this one is since the vane is rotating, okay, the velocity of the stream is going to be pushing the vane, right? Okay, but as the vane is moving, the velocity that's actually being applied to the vane will be slightly less than just the velocity of the stream. Okay, so our velocity applied is going to be v sub s minus the velocity of the vane. Okay, and then as the vane goes around and around, the next vane in line will be in line of the stream. And the way I've set this up is such that there's never any time period where more than one vane is in contact with the stream. Okay? So yeah, for the next series of videos, I'll be going over the Pelton turbine.